So here's an example of a proof that you might see where you're trying to prove something about quadrilaterals. Now, a dart, Chad, put your toys away. Yeah? Your dart, that all the electronic devices should be put away right now. So a dart is just like a kite. Except a kite has two sides next to each other that are congruent and quadrilateral, and another two sides opposite those that are also congruent to each other. So these are congruent and these are congruent. But a dart is a kite that has a dent in it. In other words, it's convex. Okay? So this is a dart, and what we're trying to prove is that BC bisects ACB. So in other words, that this piece right here bisects AC and B. So who thinks that they can come up with a method? Now, before you come up with method, yeah, side, that's true. But think backwards a little bit. In order to prove that this bisects this angle right here, what would I have to say about these two angles? That they have to be the same.
Or the triangle.
Okay, good. Okay, slow down. So now we have to work backwards. Okay, to make these angles congruent, I have to prove that the triangles are congruent. Before I prove the triangles are congruent, I have to have one of my conjectures, like side, angle, side, etc. Yes, Mr. Beaver, wait. You have side, angle, side. So let's move on here. Okay, so we're going to do a flowchart proof after we work backwards. So the first thing that you're going to do is, who can tell me what the first thing I want to do is? Yes, Devin?
CD is congruent.
Right, you want to write out the givens. All right? So where's my box tool? So I'm going to make some boxes here. And there's probably a way to make a flowchart, but I don't know what it is. So I'm going to make one box here, another box here, another box here, and then exactly what Devin said is what, Devin? What do I put there?
CD is congruent to CD.
CD is congruent. Oh, you want to list that first? Okay, let's list that first. CD is congruent to CD, and what's the reason for that? Same side. Same side. And then you're going to list what?
AC is congruent to BC.
Nice. AC is congruent to BC, and what's the reason for that? Nice, given. See, you're getting these proofs. That's given. Okay. What's next there, Haley? What's next, Sam? Who can tell me what's next?
is congruent to BD.
Stephanie, please come down. Okay. AD is congruent to BD, and why is that, Stephanie? Okay. BD, and that's also given. Okay. Now I have proof. I'm going to put these three things together. I'm going to put arrows on the end. Ooh, look at that. Okay. And I put those three things together to show in my new little box that what is true. Makana.
That triangle ACD
Nice.
is
Triangle ACD is congruent to triangle what? Yeah, name them in order of their corresponding parts. B, C, D. Okay? And why?
Side.
Side. Very good. Okay? So the next thing that I'm going to say is that, no, it's not the last thing yet. Okay? Next thing is what? Go ahead. Allison. Okay, angle ACD is congruent to angle BCD, and why is that? C, P, C, P, C, but we're not quite done, okay? It means,
Congruent parts of congruent, or corresponding parts of congruent triangles are congruent.
very good, Emily. Emily, your voice has changed. I mean, Allison, your voice has changed.
We didn't ask.
I asked Allison.
Anna asked. The whole
Okay.
class.
All right. And then, lastly, I get Emily and Allison. All right. So, yeah, maybe that's it. They both have the same amount of syllables.
I have the same one.
Yes, you do.
Emily.
Emily, Allison, they both run cross country, right? Yes. They're both quiet, hardworking students. All right. Okay. So now, what do I say right here? What do I say right here?
DC.
Yes. So now you can say that DC bisects angle ACB and what? Yeah, so that's just like definition of a bisector, okay? So we worked from kind of going backwards. We worked from going backwards to setting up a flowchart proof. So now that's kind of the way you want to do it. So we're going to do one more. In a two-column format, a little bit trickier, okay? So given that SP is parallel to OA and SP is also congruent to OA, prove that SOAP is a parallelogram, okay? So this one is a little bit trickier. And so think about working backwards. What makes a parallelogram a parallelogram? Two sides parallel sides. And all I'm giving is that one pair of sides is both parallel and congruent. So what I would do is mark up this as being parallel and also as congruent, okay? So what I really need to do is get this pair of sides parallel, right? So what would I need to know to show that those two sides are parallel? Yes?
What do you know, like all the angles?
Not all the angles, which there's two specific angles that will allow me to say that, raise your hand, that these sides are parallel. Yes? Someone else? Correct.
You'd have to say that like 4 and 3 words.
Good, okay? So if I could show that angle 3 is congruent to angle 4, then that makes these lines parallel. If these lines are parallel, then this thing has to be a parallelogram because it has two pairs of parallel sides. Follow that? But first I have to say that angle 3 is congruent to angle 4. What would allow me to say that angle 3 is congruent to angle 4? Yes, ma'am? If the triangles are congruent, do I have enough to say that the triangles are congruent? You have a side. Well, you have a side and a side, but I also need angle 2 congruent to angle 1. Is angle 2 congruent to angle 1? Why? Got it? Okay, because those are called alternate interangles. So, putting this all together, this is not, we're going to try to do a two-column proof with this one, okay? So, and there's a lot of steps here, so just kind of bear with us here for a minute. I want to make this a solid line. I want to make it green. Do I want to make it green?
Yes.
Yes.
So, this is a two-column proof, okay? You can also do this as a flowchart proof, or you can first do it as a two-column proof, and then we'll be kind of done. So over here we have statement. So with a two-column proof, you have the statement, and then you have the reason. And over here, usually I list my givens. So you don't want to always use your givens, do your givens exactly as they appear here. You kind of want to do your givens out as you're going to need them, okay? So first let's put down SP is parallel to OA. What's that going to allow me to say? Oh, why is that true? Why can I say that? That's given, okay? But then I need to use that for something. what can I use that to tell, to say?
Angle 1 is congruent.
Nice, okay? Once I know that these two sides are parallel, then that lets me say that angle 1 is congruent to angle 2. And the reason for that is alternate interior angles, okay? So we should say more like if two sides are parallel, then the alternate interior angles are congruent. But we'll just write it like that, alternate interior angles. Okay, parallel line, if you have parallel lines, then the alternate interior angles are congruent. Okay, so far I have an angle, right, over there too, that I'm going to use in my proof. Now, what else do I need to use in my proof? Right, that these two sides are congruent. So now I'm going to list my next piece. SP is congruent to OA, and that is what? That's given. Alright? So now I have a side. Yes? What else am I going to use? I'm going to use this side of being congruent to itself, right?
Yeah.
So PO is congruent to, you should really say PO congruent to OP, but we'll just say PO is congruent to PO. And that is same side, same segment, same side. Okay. Now, because I have those two things being congruent, what can I say about this triangle and that triangle?
That they're congruent.
Okay, so triangle, what should we call this one? SOP. SOP is congruent to triangle. SOP. Try to go in order. APO. I mean, I won't take off if you put them in the wrong order, but really you want to try to arrange them so that the parts line up. What is the reason for that? Yeah, even though I listed my pieces, that's a bad word. Even though I listed my pieces as ASS, it's side, angle, side, right? Side, angle, side. So the reason for that is side, angle, side. Okay? Now in step 6, I'm going to put that, what? Good, nice. Angle 3, I just put those numbers in there so it's easier for us to write. So angle 3 is congruent to angle 4. Why? C, D, C, T, C. Okay? And now, angle 3 being congruent to angle 4 allows me to say what? Nice. That PA is parallel to SO. Okay? And that's really called the converse of alternate interior angles. So meaning if the angles are congruent, then if the angles are congruent, then the lines are parallel. So you could write it as the converse of alt int angles, something like that. Alt int angles. And then now what can I say? Nice. So SOAP is a, I'm going to just draw a picture, is a parallelogram.
That doesn't look very
There, now it does. They drew little arrows. SOAP is a parallelogram because that's if a quad, so I would write something out like this rather than definition of a parallelogram. If a quad has two pairs of parallel sides, then it's a what? And it's a parallel. Okay? Parallel. For some reason this thing kind of funky when I get into one. Alright, probably the new software, glitching the new software. So that's how you would write it to column proof. You could also write this as a flow chart, okay? You like this better?
No,
Okay.
Yeah, that's better.
So sometimes I'll actually write it 2 columns, sometimes I'll actually write it closer. So we just did one of your homework problems. I think this is number 5 on your homework, okay? So, and the rest of them, the first 3 are like fill in the blanks. 6 is not too bad. The only ones where you really have to do something significant on are 7, 8, and 9. So for some reason this isn't writing. So your homework is, why is it not writing? It's invisible. Yeah, we're having all kinds. Uh-oh, it's not even letting me talk to it. We're gonna pause. That's your homework, page 296, 1 through 9, and